Welcome to episode 19 of IT 3000, where today we're taking a careful look at file permissions. At its heart, this is a small, elegant model that answers a single question for every file on the system: who is allowed to do what? And here's the detail that shapes everything else. Access gets checked the moment you open the file, not continuously while you're using it. That one design choice quietly explains a lot of what follows. So let's pin down the concept properly. Permissions are just metadata, a small tag attached to every file, riding along in its inode that declares which categories of user may perform which operations. The kernel consults that tag when a process asked to open the file, makes its decision, and then steps out of the way. And this is where the subtlety lives. If you revoke somebody's access while they already have the file open, they stay inside. The check already happened. With that in mind, the whole classic model comes down to just 4 pieces. There are 3 classes: user, group, and other, and every request resolves into exactly one of them. There are 3 writes: read, write, execute, which, on a directory, quietly shift meaning into listing, creating, or deleting entries, and traversing through. Then the special bits: setUid, setgid, and sticky, small, seldom touched, and responsible for a surprising share of security incidents. And finally, ownership, the user and group recorded in the inode, which only root can hand off to someone else. So, how does a check actually run? The kernel asks a short sequence of questions and stops at the first one that fits. If you're root, checks are skipped outright. Otherwise, if you're the owner, only the owner bits apply, and this is the subtle part, only those. If you're not the owner but you're in the group bits decide it. Failing all that, the other bits apply. This is why a mode like 044 will happily lock out the owner while letting the rest of the world read. First match wins even when it hurts. And on top of all that, every directory along the path needs execute, or the traversal never even reaches the file. Here's a moment that trips almost everyone up the first time. Picture a file owned by someone else, mode 444, read only for the world. You try to edit it, the kernel refuses, exactly as advertised. Then you delete it and it just vanishes. No error, no prompt. And that's not a bug. Deleting a file is really a write to the directory that contains it, not to the file itself. The sticky bit was invented precisely to plug this gap, which is why .tmp carries one, and why any shared folder needs the same. It's worth pausing to untangle 3 terms that often get used interchangeably because they answer the same question at very different resolutions. Classic permissions give you 9 bits and 3 classes, fast, everywhere, but blind to individual exceptions. Access control lists let you name specific users and groups with their own rights, which is powerful until you try to audit it half a year later. And capabilities take a different path entirely. They slice root's authority into discrete privileges attached to processes, and that's where modern systems have been heading. Which brings us to where this thread continues. ACLs, UMask, and setUid all refine the model we've just built, extending it, shaping its defaults, or bending its rules for specific programs. Capabilities take it further by rethinking privilege itself, while journaling and mount move us out of permissions and into how the file system actually holds together. Next up in the series, journaling, how the file system stays consistent when things go wrong mid-write. So, to gather it all in one place, 3 classes, 3 writes, 3 special bits, 2 owners, that's the whole classic model, with no other moving parts. Remember that permission checks happen at open, and only at open, which is why revoking access won't disturb a handle that's already been granted. And keep in mind that on directories the rights read differently and delete permission lives with the directory, not the file it contains. Small model, quietly powerful, and now hopefully a little less mysterious. See you in the next one.